Welcome to the how-to for converting moles of one reactant or product to moles of another reactant or product. First, we need to understand what information we can get from a balanced chemical equation. And so when we look at a balanced chemical reaction, as here, where we have two hydrogen gas molecules plus one oxygen gas molecule, produces two water as a liquid. Well, we can think about this at the molecular interpretation, where that means that we have 2 moles of H2 gas, so 1 and 2. We have 1 molecule of oxygen gas reacting, and that's going to produce a total of 2 molecules of water. But we could also talk about this at the mole level interpretation, where we have 2 moles of H2, where this coefficient of 2 really just means 2 moles of H2, would react with 1 mole of O2, and that can produce a total of 2 moles of H2O. If we took moles of H2 and converted that to grams, we would get 4 grams of H2, moles of oxygen, 2 grams of oxygen gas, 32 grams, and 2 moles of water converted into grams is 36 grams of water. Now, you can note that there is a conservation of mass. But when we want to compare moles of one reactant to moles of another reactant or product, we can't use the mass, okay? We have to use the moles. And so in this example problem, where we're really trying to convert from 1.57 moles of oxygen gas, okay, and we want to figure out the number of moles of water produced. Well, in this case, we're comparing moles of one reactant or product to moles of another reactant or product, and so what we do is we look at the chemical equation in terms of moles. And so we see that we have 2 moles of H2 for every 1 mole of oxygen produces 2 moles of H2O. And so in these types of problems, you're going to start with what's given, which is 1.57 moles of O2. We want to know how many moles of water is going to be produced, and so what we need is some kind of conversion factor. So it's a dimensional analysis problem. And that conversion factor that we're given is really telling us that we have 2 moles of H2O for every 1 mole of O2. That is our conversion factor. And so in that case, we say, okay, well, we know we need 1 mole of O2 on the bottom, so our moles of oxygen cancel out, and we're going to produce 2 moles of H2O. This gives us a total of 3.14 moles of H2O. Our moles of oxygen canceled out. And so really all we did then was convert from moles of substance A to moles of substance B using the coefficients of the balanced equation. Lastly, we can kind of look at an overview of this where we just calculated this bottom portion, where we went from moles of oxygen gas to moles of water using the coefficients of the balanced equation. But most of the times you may be given grams of the first substance, maybe grams of oxygen. We first have to convert that to moles using the molar mass. Then we can convert those moles to moles of another product reactant. And ultimately we could convert those moles back to grams. Again, it's important to understand that we cannot convert directly from grams to grams. Anytime we want to compare one reactant to another, we have to convert that to moles first. That completes how to convert moles of one reactant or product to moles of another reactant or product.